In example 4, we need to write both a sine and cosine equation for the following graph. So I'll do the sine here in purple, same as the last video, and we'll do the cosine one here in blue. And we're going to go through this one a little quicker. So if you do need to get a better explanation, please watch the previous video on example 4. Also, it's hard for you to kind of see the bottom of this graph. I'm going to move that up just a touch. I think that's barely in the viewing window, so I hope that you can see this example at home. I had to blow it up a little bit so you could get a better vantage point. Let's begin by writing the sine. So we'll do y is equal to, and you will notice that the midline would be somewhere in here. And this graph, if we plotted a point here, would begin up first, just like this one. And we can change this later if we need to, but I think we're going to leave this as being a positive sign right here. So again, what I like to do here is I just draw my top line and my bottom line and my midline. So there's the top line. Come down here, and again, I apologize if this is a touch off the screen there. And then I think this is at -7, and this line here is at 1. So 1 to -7 is 8, and if I go 1, 2, 3, 4 units down, that'll be 1, 2, 3, 4 units from the bottom line. So right away I know that my A here is going to be 4, and we're going to leave it not reflected right now. We can change that if we need to. So that's our amplitude. Remember, our amplitude is from our midline to the top line or from the midline to the bottom line, but it's always, the amplitude itself is always positive, and whether or not you want the graph reflected is what you can do with the negative sign over here. Alright, so we've got that. We also have the shift. The shift is going to be down 3. So let's do sine. We'll leave a little bit of space. And then we'll do down 3. Remember, the shift down, up and down, vertical direction, you just write whatever direction that is. If it's left and right, the phase shift, we're going to write the opposite. Now we need to figure out our period. So it looks like from this point to this point is pi, or from pi over 2 to 3 pi over 2 is pi. You can pick any point as long as you get one full period or one full repetition of the y values, you're good to go. So our period would be pi. And we're going to set that equal to 2 pi over k. Now, just looking at this, I mean, you don't really have to solve this. K is 2. 2 divided by 2 is 1, and then you just got pi. If you did solve it, you'd find the same darn thing. So it's going to be 2, and I'll do theta this time. You could put an x there if you wanted to. And that'll be the same for the cosine. So we're going to borrow a lot of stuff from the sine here. And then what we need to do, though, for the sine is we need to figure out if we graphed a normal sine curve here with like just this part without the phase shift, here's where it would be. We'd start right at the midline. We need to come back to the midline halfway through the period and then wind up here again. So we know that the top will be here and the bottom will be, if you split each half into another half and the whole thing into quarters, that here is what the graph will kind of look like. And again, this is just a helper graph to help us see which direction we want to shift. And now we need to take this purple graph and shift it onto the black one. So I think we're going to shift by this distance right here. And if this is pi over 2, then this distance must be, that's an x value of pi over 4, y value of 1. So we're going to go pi over 4 to the right. So we're going to have to put a negative sign right here. And we now know that the shift is pi over 4. We've got our sign correct, so we don't have to worry about it in the equation here. We've got c over k. So we just multiply by 2, simplify that fraction part. You've got pi over 2 is equal to c, and that'll be the value that will go right here. So the sine is done, and you could also take any point on the black graph, which doesn't matter where it is, it should work for this equation. So if you did that, you could totally check your work. You could do pi, and you could see if, you know, an output or the y value is -7 for pi. Let's, you know, for grins, let's do that here. So we've got -7, we hope, and we'll do 4 times the the sine of, we're picking pi. So this is a coordinate right here. This is pi comma -7, and an x and a y, or a theta and a y. And so we can choose this, and 2 pi minus pi over 2 is 3 pi over 2. We'll subtract 3. So if you remember the sine of 3 pi over 2, that angle is down here on the unit circle, and so that y value is -1. And indeed, we get -4 minus 3, which is -7. So this does check, and you can check this to your heart's content. Any point on the black graph should work in the equation that you've written. All right, now for the cosine. Let me switch pens on you here. So for the cosine, lots of stuff is going to stay the same. And let's see if we need to reflect this first. Yeah, I think a reflection would be good because we're starting here at the bottom line, then coming up, and then we won't even have to worry about any phase shift, so that'll be nice. So let's just use a reflection here, and we'll put the negative sign in. The amplitude for each one of these graphs is the same, so that value will be the same. We've got cosine. The period didn't change; that didn't get stretched out or anything, or excuse me, yeah, stretched out or anything like that. So that's fine. So 2 theta should be good. And for this one, actually, if we plotted those points without any phase shift, we'd be right on this sucker anyhow. So we can just close it off, and then we can put the -3. So actually, if we can figure out for some of these, it makes it easy. If the points are already on the graph, that's nice. And if you know about reflecting, that's nice too. We could have shifted without a reflection. We could have shifted right by pi over 2. So if you did that, and I'll just put, you could do this, I'll put a little star here, and if you said, hey, the phase shift, I don't want to use a negative sign here, I don't want to reflect it, I just want to start it right at the top line, then we would need to take that point and shift it over right by pi over 2. So we can do pi over 2 here is equal to c over k. C, of course, you can tell has to be pi. And so now we could write this equation having a +4 here. The cosine of 2 theta, now it's to the right, so we need to put a minus sign. Pi is the value of c, then -3. So this one also works. If you just said, Mr. Valsa, I need to shift this, I don't care. I'm tired of reflecting for some reason. Maybe you're looking at yourself in the mirror too much, I don't know. But you said, I want to shift this darn thing. So, okay, fine. If you want to shift it, that's fine. You'll have a value of c here. And it also works. Lots of different ways. And I'll just kind of circle this in as lightly as I can. Because this one's fine. You don't have to come up with another one. But here's one that would have a shift.